Hello everyone, I am Ritika Zuzgar, Assistant Professor IT Department. So in this lecture we discuss about what is meant by polynomial regression. Okay, so in previous video we already discussed other types of regression, that is linear regression and logistic regression. Okay, so also we discuss the overview of polynomial regression. So in this video we discuss about in detail what is meant by polynomial regression and the equation of a polynomial regression and also the need for the polynomial regression. Okay, so polynomial regression is a regression algorithm that models the relationship between the dependent, that is y variable, and the independent variables, that is x variables, as a nth degree polynomial. So the polynomial regression equation is given below. So what is the polynomial equation? Y equal to b0 plus b1 x1 plus b2 x1 square plus b2 x1 cube plus bn x1 raised to n. Okay, so this is the polynomial equation. So it is also called the special case of multiple linear regression. Okay, linear regression contain two types: single linear regression and the multiple linear regression. Okay, so polynomial regression is also the type of a multiple linear regression. So in machine learning, okay, so because we add some polynomial terms to the multiple linear regression equation to convert it into the polynomial regression. So this model, so it is a linear model. Okay, so this polynomial regression is a linear model with some modifications in order to increase the accuracy. For the more accuracy, we can use the polynomial regression instead of the linear regression. So the data set used in the polynomial regression for training is of a non-linear nature. Okay, so if you are having some data set for a non-linear fashion. Okay, so in this non-linear type data, we can use the polynomial regression. But if we are having a linear type data, so in that case, we can use the linear regression model. So it makes use of a linear regression model to fit the complicated and the non-linear functions and the data set. So in the if you are having a data set in the non-linear fashion and if you are having a complicated data set, okay, so in that case we can use the polynomial regression. So in polynomial regression, the original features are converted into polynomial features of required degrees, that is 2 degree, 3 degree and n number of degree, and then modeled using the linear model. Okay, so see here in this equation we are using the degree of 1 degree, 2 degree, 3 degree up to the n number of degrees. Okay, so that we can model our data set in the linear manner or a linear fashion. Okay, so next point is a need for a polynomial regression. So the need need of a polynomial regression in machine learning can be understand by some points. So first point is what if we apply the linear model on a non-linear, or if you are applying the linear model on a linear data set. Okay, so then it provides us to good result as we have seen in the simple linear regression. Okay, so this point we already discussed in previous video in the part of a linear regression. Okay, so if we are having a linear type data set, so we can model our data in the linear regression model. But if we apply the same model without any modification on a non-linear data set, okay, then it will produce a drastic output. So due to which loss function will increases. So the error rate will be high and the accuracy will be decreased. Okay. So for such cases where the data points are arranged in a non-linear fashion, so we need the polynomial regression model. So we can understand in a better way using this below comparison diagram of the linear data set and the non-linear data set. So in this image we have taken a data set which is arranged in a non-linearity. So if we try to cover it with a linear model, then we can clearly see that see that it hardly covers any data points. So in other hand, a curve is suitable to cover the most of the data points, okay, which is the polynomial model. Okay, if you are using the linear model, so some data points are lost in this regression line, but if you are using the polynomial model, all the data points are placed in this line. Okay, so this is the polynomial model. So if the data sets are arranged in a non-linear fashion, then we should use the polynomial regression model instead of the simple linear regression model. Okay. So the polynomial regression algorithm is also called as a polynomial linear regression, okay, because it does not depend on the variables. Instead it depends on the coefficient which are arranged in a linear fashion. Okay, what are the coefficient here? In this equation, b0, b1, b2, b3 up to the bn. So these are the number of coefficients are used in a linear fashion. The next is the equation of the polynomial regression. Okay, so we already discussed the equation for a linear regression, simple linear regression also, and multiple linear regression also. So we are comparing here the linear regression with a polynomial regression equation. So in the simple linear equation, what is our equation? Y equal to b0 plus b1x. So instead of b0 b1, we can write a0 a1 also, or some other terms also. Okay, like y equal to mx plus c. So here m is the coefficient and also c is the coefficient. Okay. So in the multiple linear equation, y equal to b0 plus b1 x plus b2 x2 plus b3 x3 up to the bn xn. So this is the multiple linear equation. And in the polynomial regression equation, we have an equation like y equal to b0 plus b1x plus b2x square plus b3x3 x cube plus bn x raised to n. So when we compute these three equations, we can clearly see that all the equations are polynomial equations but differ by the degree of variables. So the simple and multiple linear equations are also polynomial equations with the single degree. Here in the multiple linear equation we are having only single degree, but in the polynomial regression equation we have the second degree, third degree up to the n number of degrees. So the polynomial regression is a linear equation with the nth number of degree. So if we add a degree of our linear equation, then it will be converted into the polynomial linear equation. Okay, so this is the concept of polynomial regression. Thank you.